In this lesson, we'll continue exploring A-Frame and you'll keep on learning core foundations so that you can build any sort of project with this library. But before we move any further, I wanted to show you a couple of websites here that I didn't mention before. So in here on the homepage, if you go to community, you'll get access to a few pages here that are very important. So there is the documentation, which we'll be using in this particular lesson. And there are two sites here that are important to check out as well. So one of them is the GitHub repository. That is in case you are interested in following the library even on a day-to-day basis, because there are updates here daily in terms of the code. And you can always join as a collaborator as well, if that's something you want to do. And then there is also the Slack channel, which is a great way to get real-time interaction with developers that are working with this library. So if you go here, Slack, it is basically like an online chatting tool that is free to join, and then you can chat to other people in real time that are using this library. So that is their basic support network. Basically, they also have social accounts and a mailing list if you want to learn more about that. All right, so let's continue exploring what can be done here. So I'm gonna go back to my project, and what I've done here is put what we did before in a folder named 01. That's what we did before, and I created a new folder 02, and I have that same file in there. I've also loaded that second file on my local web browser, and so for that I simply changed the folder here that we are at, and I've opened that in my code editor as well. So what I want to talk about here are two other transforms that we can apply to a model here, or a mesh. So I'm using a lot of words here, right? So let's start from the beginning. When I talk about position, what we are really doing is applying a translation transformation. So we are transforming a box by moving its position to this place, because by default the position is 0, 0, 0. So we are applying what's called a transform, and this is a concept commonly used in 3D modeling, in 3D tools. Now, when I talk about a model or a mesh, I'm talking about 3D objects that are represented by vertices. Let's bring up the drawing application here. So a mesh or a model is, let's write that down, is represented by vertices that are points in space, and then these are vertices, and they all have coordinates x, y, z, x, y, z, and then the vertices are joined by what's called edges. So that's an edge, and these terms are common to all 3D applications. So you can have something like that, and once you have 3 or more edges that are joined together, you can have what's called a face. So you can have what's called a face, which is basically that. So in 3D modeling, you can have what's called transforms, and that can be a position transformation, but you can also have rotation and scale. Let's improve this a little bit. So let's talk about rotation. You can have rotation about all 3 axes. So you can have a rotation about x, about y, about z. So those are 3 different numbers. By default, you don't have. By default, all these models you create don't have a rotation of 0. Now, when is a rotation positive and when is a rotation negative? Since we are on a right-handed coordinate system, a positive rotation is when you use your thumb to point at the positive direction of your axis. So that could be z, or it could be x, or it could be y. And then you use your other fingers to close that rotation, to make that movement. So that will define a positive rotation. And that is specified in angles that go from 0 to 360 to do the full circle. So that is the rotation transform. And I'll talk about scale in a minute. Let's first do something with rotation here. So let's rotate our box about the y-axis. So that is, we are going to literally rotate it in this way. So the y-axis points up. So we are going to be rotated about the axis that points up. So we're going to type here rotation. And then we have to enter the values for x, y, and z. So for x, we're going to leave that at 0. For y, we're going to rotate this we're going to rotate this 45 degrees and no rotation on z. So I'm going to save that. And I'm going to go back here and I'm going to press F5 to refresh the page, or press refresh here, reload the page. And we should see that, that rotation taking place. So let's try a different value here, like 90, for example. And we can see how it's rotating about the y-axis. And if we set this back to 0, we should have the initial figure. And when we enter 90, it looks the same as now, because it's basically a cube that looks the same in all directions. So it will look the same from all different sides. Okay, so that is rotation, and you can of course combine rotations on different on all the different axes. So you can have a rotation that is something like so, and then you will see that it is rotated about all 3 axes in different angles. Now, what about the other transform that I mentioned, scaling? So let's take a look at that. We can also scale a model, for example, a cube in this case. We can scale it on all different axes as well. And what that means is that you are basically multiplying the size by a certain number. So by default, the scale is 1, which means that whatever size this has, we're not changing that size. So if you set a scale, for example, a scale on, in this case on x, if you set a scale of 2, and this is the x axis, then our cube will be twice the size on that particular axis. So the new cube, will look like so. It's no longer going to be a cube, it's going to be a box. So you can increase the size by changing the scale, and you can also decrease the size by entering a value that is less than 1. So if you say, for example, 0.5, that will reduce the size by half on whichever axis you specify. So let's go and do that to our box. So I'm going to keep that rotation there just to leave it so that you can play with that value. But I can go here and change the scale. So let's say that let's set the rotation just to 0 so that we don't get distracted by that. So let's say that I want my cube to be twice the size in x, and I want it to be the same size on y, so it's the same height, and it's going to be half the size on z. And we can actually go here and have a second cube so that we can compare both cubes. So we will position these, let's position this in 2 here, or in 3, so there's more separation between them. They have a width of 1 in all directions by default, by the way. So this one is not going to have the scale modified, so that it's easy to compare both of them. So let's go back here and refresh this page. And you can see that this one is the one we've modified. So on x, which is this axis, it is twice the size. And it is the same height as the other one, but the depth has been reduced by half. So those are the 3 basic transforms that you can have. And now something else that I want to specify to talk about is that you can have elements that are children of other elements in here. For example, you can have an element that is positioned on, let's say, a certain point, and then inside of that element you can have other elements, other objects, other cubes, or anything else. And then if you change the coordinate of the parent object, it will move all the children objects as well. And if you scale the parent object, it will also scale all the children objects. So let's see how we can do that. So for that, I'm going to add another element here, and I'm going to make this like an empty element, if you will, and an element that doesn't really have a geometry of a cube or a sphere or anything like that. So that is going to be called an entity. That is like a neutral type of element, which you can then transform it. You can then make a cube or make a sphere. So an entity will be, in this case, a containing object. So let's go and add a containing object, and let's position it somewhere. Let's position it on X. Let's do minus 2 here. Let's position it on 0 and minus 1, so it's a little bit closer to us. So if we go and open this, we're not going to see anything because there's no geometry there, so we don't see anything new in our scene. So we want to put things inside of this. So if we go and we add a box, the position of that box, whichever number we enter here, is taking the position of the parent as the origin. So if we say 0, 0, 0, the position of the box is not going to be 0 in the world, in the scene coordinates. It's going to be 0 on the parent, so it's going to be in this position. So let's go and do that. Let's give this a color. And by the way, for color picking, I've installed here a color picking plugin for Atom. So I'm going to File. If you are using Atom, I've done this by going to File, Settings, and then here Install, and I just searched for color picker. And I found one here, and I clicked Install. I think it's not going to show now. Oh yeah, there it is. I already installed it, so it will show here, and you can click Install. And then you have the buttons you need to press on a Mac or a PC to open it. So on a PC, it is Control-Alt-C. That gives me a color picker. So I'm going to go and pick a color. Let's pick this blue. So I'm going to click here. And actually, I want the hexadecimal value. So I'm going to go here again, pick some other blue. And actually, I'm going to pick like a dark green. And click here, hex. So I'm going to click here, and that gives me the hex color. And I'm going to close my A-box element. So let's go and see what we get in the browser. So press refresh the page. So we've got our box there. That is our box, and we can go and add something else. So let's move this up a little bit. Let's move this to 2, and I'm going to add another box. And this box will go underneath that previous box, so it will go on 1. And for this, I'm going to pick a certain brown color. So let's find some color here that we want to use, and save this, and press refresh. So we've got both of them there. And what I'll show you now is if I go and I scale the parent down, so I go to the parent object and I give it a scale 0.5, 0.5, 0.5. We are applying that transform to all of the children, so now it looks much smaller. And the children can also have their own transforms, and those will be applied on top of everything you applied before. So we could say that the parent object there was that this was something like the top of a tree, the foliage of a tree, and this is the trunk of a tree. So this could be a scale of 0.2, and we can keep the same height, 0.2 here. And all of a sudden, we can have a simple low poly tree in a very easy way. And then you basically created a tree in this manner, so then you can create more trees, and you can place them in other parts of your scenes. We can place trees everywhere that we want, really, and we have something like that. Now, what exactly is taken as a position here? The position is the center of the mesh of the cube. So the position here is the center of the cube. And so if you give your cube a certain coordinate, if that is the position you are giving the cube, that will be the center of the cube, and that will be positioned basically if you have the inside of your cube, something like that. The point that you put in the middle is in the middle. Let's do this again. So the position of the center of this cube, will be in the middle on all the coordinates. So it will be half of the it will be x. This will be the position x. This will be the position Z, and this will be the position Y. So the point, I guess, will be somewhere inside there. So if we bring this down, it's something like that, and this is like a sort of half of the height. So in that part, in the case of the tree, they both by default have a size of 1. So we position one in y equals 2, and we position the other one in y equals 1. So that is why they are like that. And so if we reduce the y by, on a scale of 0.5, the new cube will be still the center of the cube will still be in the middle, the center of the box, I mean, because it won't be a cube. So let me go and do that just to show you. Here's our tree. If I go and I reduce the size of the y here, we will have that floating in there. So as you can see, there is a difference between both of them. And so if we wanted to do that, then we would also have to adjust the position in y. But I will leave this as 1. Basically, the takeaway here is that the point that you specify for position is the center of the box, and that point is not going to change if you scale the box up or down. So if you scale your box, you need to adjust the position if you want the center of the box to be at a different place. Well, that is all for this lesson. In the next lesson, we will be introducing more primitive shapes. So we'll be looking at spheres, at cones, at cylinders, and we'll be looking at more things that this amazing framework has to offer.